million to RI for Topsail Island, and then 1.6 million directly to the town of North Topsail Beach. And just a quick summary of looking at what we received. This is what we've done: 3 rounds of estimates from local governments. Coley reached out to all the towns and counties asking what their damage assessments were for Florence, and these are the numbers, the latest numbers as of February 27, 2019. The numbers are very large. Just wanted to point that out. And if I'm going to turn it over now to Eric Morse to give you the summary. This is the most important part of the presentation, the summary of our water quality monitoring post-Florence. And I think if you have any more questions, Eric's presentation may answer a lot of those questions.
Thank you. Good afternoon, committee members. My name is Eric Morse. I'm the branch chief for the Intensive Surveys branch of the Water Sciences section. We help coordinate this response with working with the ambient monitoring system and the regional offices. Let's see here. Oh, wrong way. There we go. And I'm pointing. Yeah, okay. So Florence hit the coast as a Category 1 storm. It barreled across the Atlantic as a Category 4, parked itself just off the coast, and dumped unprecedented amounts of rain on the Wilmington area and the entire southeastern coast of the state. We closely followed the tracking app, as you saw earlier in the presentation here, and relied on historic sites, on historic ambient monitoring system sites for a comparison point, as well as tried to seek a little finer resolution in following the incidents as they came in. Almost 2,000 incidents were reported to DWR, and we've used Hurricane Matthew as a close reference point for some of the data that we've got collected here. You see the 2 storm tracks on the image to the right. North Carolina was already experienced one of its wettest years on record prior to the arrival of Florence. The map you see in front of you is a 7-day accumulation from September the 11th until September the 18th. Surface and groundwater storage capacity was already maxed out prior to the arrival of the storm, prior to the arrival of up to 30 inches, over 30 inches between Lumberton and Havelock. Florence broke North Carolina's record for the most precipitation from a single storm event, as recorded in Elizabethtown at 35.93 inches. The former record had been held in Southport from Hurricane Floyd at just over 2 feet, 24.1 inches. And I would like to remind you also that about 3 weeks following this event, or just shy of a month following this event, Hurricane Michael barreled across the state and hit the central area part of the state with quite a bit more rainfall on top of these totals. We'll get back to discharge if we need to. We'll try to trim some of that. Our flooding events throughout the state, we'll kind of work north to south on that. The Roanoke Basin saw peak stages at the 3-week mark after landfall. Part of that, again, was due to that later arrival of Michael. The duration of flooding was 4 times that experienced during Hurricane Matthew, again, just in the Roanoke Basin. Michael flooding came in from the 19th, so basically over a third of October was spent over the National Weather Service's flood stage levels in the Roanoke River Basin. The Tar River saw minimal impact as compared to Matthew, which saw over 10 days, or 10 days at flood stage. There were 0 days over flood stage in the Tar River Basin. The White Oak, the poor little White Oak in Jacksonville, probably bore the brunt of this event. We had stages 7 feet higher than Matthew and 4 days longer above flood stage. Although it peaked just 1 day after landfall of the event. If you'll notice the top right, this flashy peak here in the White Oak Basin, having such a small drainage, its impacts were felt almost immediately and subsided in time. Just 1 day after landfall, but that value represents over 40 times the baseline discharge. Where is that value? So we've got baseline value for the White Oak is at 550 cubic feet per second versus the 24,000 cubic feet per second experienced during this storm event, which was the equivalent of 7 times that experienced during Hurricane Matthew. And this set a new record at this particular basin, this particular gum branch off the New River in the White Oak Basin. The Cape Fear experienced its second highest peak stage on record at Lock and Dam 1. This represented levels higher than Floyd and higher than Matthew, with 4 feet, in excess of 4 feet from the Matthew peak stages, and a duration of 3 days, 3 days longer than those experienced during Matthew. Those values are represented here. You'll see the asterisk. This gauging station went offline for a day, or 2 days rather, during this event. But looking at the rest of the hydrograph, it's pretty safe to say that those areas were indeed above flood stage as well. Let's see, working our way on to the south, the Lumber River exceeded Matthew stages by almost 3 feet, and likewise set a record at the Maxton site for a high peak. These two maps represent the data I just discussed on the table, just in tabular form. You can see the hydrographs as they appeared in these 3 northern basins, and you can see the sites marked out along the map as to where these hydrographs were recorded, and then the 3 southern basins of the White Oak, Cape Fear, and Lumber. As far as our water quality monitoring response effort, again, these sites were determined based on historic comparison, having some background data. These are all ambient monitoring stations with long data histories. We had some main stem sites, and then we also studied the tracker app as it came in and sought some higher resolution up some of the tributary streams. All 17 of North Carolina's river basins were affected by this event. Our monitoring focused on 9 basins in 31 counties to the far east of the state, but reaching as far west as just south of Charlotte, we wanted to see what was heading out of the state, so we'll see some data from that point. Again, the effort to evaluate the potential impacts of almost 2,000 incidents that were reported to DEQ over the course of this event. Physical parameters that were monitored during this event were temperature, pH, DO, and conductivity. Those were all collected on site with handheld probes, and then chemical samples at all sites, minus the metals sites, which we'll handle by themselves here at the end of the presentation. All sites were sampled for fecal, coliform, biological oxygen demand, total suspended solids, turbidity, and nutrients. As situations indicate, as reported incidents indicated, some sites were also sampled for volatile organic compounds, semi-volatiles, pesticides, herbicides. Excuse me, I take that back. We did not sample for pesticides, herbicides. All of our Matthew samples were non-detect for those, so we passed on those parameters this round, more out of necessity. You can see those sites broken down with a little higher resolution if you're interested in some of where those are. I've also got those in tabular form available for you as requested. So you'll see some summary stats a little later in the presentation, and those were derived from these 4 upper state sites, 1 in the Roanoke, 1 in the Tar, and 2 in the Neuse. And moving south, we have 2 sites in the Cape Fear, 1 in the White Oak, and 1 in the Lumber River Basin that will provide some summary stats for. So, let me back up, just to explain what we're talking about here. So you're going to hear me refer to baseline conditions, and the baseline values that I'm referring to in this discussion are these 2012 to 2016 AMS median values. Those were pulled from the 2018 integrated report for these sites. And we'll also refer to the Matthew values. And this is where it gets a little tricky, and I apologize. The Matthew phase 1 average represents what we will discuss here as round 1 and round 2 of the Florence sampling. So the Matthew data, which is this purple bar, at the number 5 location can be compared to the average of bars 1 and 2. Okay, so this is round 1 versus round 1 and round 2 versus the purple. Purple is our Matthew equivalent. Am I clear on that? I feel like I'm stumbling over that comment. Okay. Rounds 1 and 2 averaged are the equivalent of the Matthew phase 1 average on these following tables, okay? Following graphs. So for our surface nutrient values, there is no surface water standard for nutrients in North Carolina. However, we do have those historic values for comparison here. Total phosphorus was seen as being higher in their Matthew equivalents at 6 of 7 sites. Again, this is round 1 and round 2 versus the Matthew data. And at the conclusion of this study, which was at the end of round 4, 5 of the 8 sites were still above our baseline value. Backing up just for a second, I apologize. Phase 1 was basically the first 4 weeks following the storm. There were 10 days prior to our initial sampling. As soon as roads were safe and we were getting reports that we could get in and out of these sites, we began the sampling effort, although the sampling around coal ash facilities began at day 8. So from September the 22nd until October the 19th was the phase 1 effort. That consisted of 55 sites statewide. We reassessed at the halfway point and dropped a few of those sites. So at phase 2 was what we're considering the recovery period versus the acute impacts period. So phase 2, which represented here as rounds 3 and 4, was from October the 22nd until November the 26th. Okay, so let me jump back in here. So the total phosphorus was seen higher than Matthew values at 6 of 7 of these sites assessed. 5 of 8 of which were still above the baseline by round 4. Total nitrogen was higher than Matthew equivalents at 5 of 7 sites, with early peaks at Rockfish Creek, which is 947 here, and Contentnia Creek, which is a nutrient-sensitive water in the Neuse Basin, 781. The early peaks of total nitrogen are primarily organic source nitrogen. Later rounds were more, the greater contribution was seen from nitrate and nitrite. And then 5 of our 8 sites were back to baseline conditions by round 4. So we were starting to see some recovery, more in nitrogen than in phosphorus at that point. Biological results, some fecal coliform results were impressive. We had some early spikes in these small watersheds. Again, 947, that's Rockfish Creek. That's a lower Cape Fear basin, sub-basin, with a fair amount of agricultural activity. There's also a wastewater treatment plant just upstream from this site that was offline through some of this period. So some interesting contributions going all over. Round 1 and round 2, at most other sites, we see a dilution factor cutting down those coliform counts, just the sheer volume of water. But as we return to base flows, especially with the results of some of the upstream flood control measures, we're letting less water out of the dams, so base flows taking contributing a greater portion to those levels. So we're probably seeing some of our higher coliform levels as a result of that as well. Our peak fecal coliform value during this study was 60,000 units at Sugar Creek, just south of Charlotte. Most of these other peaks were to the east of the state. The values that are going off the table here are enumerated by between 13 and 3,100 colonies per unit. BOD, high levels of BOD early on in the survey also indicate releases of untreated wastewater. The BOD levels are fairly comparable to Matthew, minus, again, some of those early spikes we saw. There is no surface water standard for total suspended solids, and I apologize, there should be a turbidity standard of 50 drawn, a line for 50 on turbidity, so the only exceedance we saw there was late in the game on main stem Cape Fear. There was a lot of flood control going on upriver at that point. I wouldn't venture to guess as to what the direct cause for that was, but we had higher levels witnessed in the Neuse and Cape Fear basins later on in this study for turbidity. Volatile organic compounds and semi-volatiles were collected from a subset of our sampling locations. The only detections of any of these compounds were observed at Sugar Creek outside of Charlotte and just upstream of the Port of Wilmington. And I apologize, the standard cited here is in error. That is a freshwater standard, and the detection we see of toluene is an SC classification. That's a saltwater system. Again, that's just outside of Wilmington. We have no standards for any of those values. Those detections are largely components of fuel, not particularly the full product, the gas or diesel product, which we tested for with the TPH gas and diesel analyses, but individual components are fuels. Physical results, dissolved oxygen fell off early as a response to the excess wastewater and the flushing of swamps and wetlands. Some fish kills were reported as a response to that. There were 13 citizen reports as reported to a tracker app that we maintain at DWR, and 8 confirmed kills by DWR staff in the Roanoke, Cape Fear, and Waccamaw basins. The Matthew equivalents also, again, carry across to this graphic, and you can see dissolved oxygen for Matthew was higher in most cases than what we're seeing in the combinations of rounds 1 and 2 of our sampling here. I don't know how well that speaks to whether we're better prepared or doing a better job than last time, but this was a different storm event. It's hard to compare apples to apples in that event, but we saw some values in excess of what we observed during Matthew, for whatever that's worth. Let's see, by round 4, in fact, for all of phase 2, all of our stations monitored, not just the ones represented here, but statewide, all of our DO readings were back above that 4 milligrams per liter. That's an acute, instantaneous standard as opposed to the chronic 5 milligram. The reason you're seeing 2 different standard values represented for pH, some of those are swamp classification, which allows for a lower DO value of 4.3 versus 6. We had very few, if any, I apologize, we didn't have any pH violations. I'm sorry, yes, we did have a couple of pH dips. I won't say violations, excuse me, exceedances. There's no one to point a finger to with an exceedance like this. And in comparison to those values for which we do have some standards, this is just a quick summary table across the board to reflect those values. So as far as exceedances go, phase 1 versus phase 2, I'm tripping over that language myself. Phase 1 versus phase 2, the dilution factor minimized some of those fecal coliform concentrations in the earlier phases of sampling, and as we returned to base flows, saw an increase in fecal coliform exceedances. pH exceedances, while that number looks inflated in the second phase, that's primarily a result of a reduced sample set. We had 4 exceedances in both phases of sampling, so we're just seeing a difference in percentages. And then as you can see, dissolved oxygen, while we had quite a few exceedances of the standard during the first 2 rounds of sampling, everything was back to a safe concentration by phase 2. Coal ash monitoring following this event was conducted at the 8-day mark. We had sampling at the Sutton site in Wilmington. The following day, on Sunday the 23rd, sampling began at the Lee plant in Goldsboro. The Dan River plant in Eden and Cape Fear and Moncure were both visually inspected. There was no evidence of erosion, of loss of coal ash residuals or overlying materials, so no metal sampling was conducted surrounding those sites. Sutton was sampled daily from September the 22nd until October the 5th, and then weekly through November the 11th. Total arsenic was detected in 15 of 48 samples at the breach location. So the breach is at the ash basin. We have above and below sites which were unique to this study, and then we also have historic ambient data with some historic metals data at these locations, but we were initially guests of the utility there who ferried us out onto the river, so we were limited in where we were and were not able to sample, but we did our best to represent the conditions on the ground. So samples were collected at the breach site as well as above and below that breach site on the main stem of the Cape Fear River. So 15 of 48 samples at the breach site were detected of total arsenic. The maximum value detected was 7.1 micrograms per liter, where the standard is 10. Surface water standard is 10. Maximum selenium value at this location was 1.2 micrograms per liter against a standard of 5. Neither of those metals were detected in the main stem sites, only at the breach location. Zinc was detected in 3 samples, one at the breach site and one above and below in the Cape Fear proper. That standard is calculated on a case-by-case basis depending on the hardness on site. The calculated standard for the 15 microgram per liter detection at the breach site, the calculated standard there would have been 22. The main stem detection of 13 micrograms per liter, that was the maximum detection, can be compared against the calculated standard of 81 micrograms per liter. Copper was detected above the water quality standards at this site. However, that occurrence was both above and below the Sutton site. Some common metals detected at all of these stations included aluminum, barium, iron, manganese, and strontium, for which there was no standard. The Lee plant, did I jump ahead there? I sure did. The Lee plant in Goldsboro was sampled beginning on September the 23rd, which was the Sunday following, 11 days following the event on the 11th, or the 12th. And then weekly samples were collected at these locations until November the 2nd. Copper again was detected above and below the site with a maximum value of 2.6 micrograms per liter, below the calculated standard at the time. Total lead was detected in one sample downstream only at 23 micrograms per liter, and total zinc was detected in one sample downstream only at 10 micrograms per liter, both of which were below the calculated water quality standard at the time. So in conclusion, in response to nearly 2,000 incidents reported to the division during, including sanitary sewer overflows, wastewater plant bypasses, inundations of breaches of animal waste lagoons and coal ash facilities, and numerous other threats to surface waters of the state, DWR personnel made over 200 supplemental site visits spanning 9 river basins in 31 counties, collecting over 700 chemical samples and in situ measurements, which resulted in over 13,800 unique data points for this event. Staff from every section of DWR contributed. I would like to recognize the regional office staffs, particularly the estuary monitoring team, and Aaron Harris in the Wilmington region. He was 6 months into the job where he found himself out on the swollen Cape Fear River collecting probably some of the highest profile samples he may collect in his entire career here outside of the Sutton plant. My own staff of 7, very dedicated field scientists who covered the majority of the Fayetteville, Raleigh, and Wilmington region in the first 2 rounds of this effort, as well as the central lab, the water science section central lab that experienced about a little over a doubling of their workflow for the 2.5-month period that this study took place. And with that, I'll open this up to any questions that you may have for Jim or myself.
Any questions or comments? That was very, very interesting. Both of you, thank you, thank you. And Christine, wherever you are, thank you.
Mr. Chairman, I'll just make a comment, which is this is fascinating information. I suspect you're probably still going to be continuing to sort of go over and analyze this for some time to come, especially for how do we deal with this when the next storm comes through and continue to get that baseline data. So thank you for putting this together.
Absolutely, and we're continuing to monitor these sites. The ambient monitoring still goes on monthly, not necessarily all these supplemental parameters, but nutrients and fecal coliform respectively ongoing.
Dr. Lazar.
Just about that, are levels back to normal, back to baseline?
I don't know. We kind of had to cut it to get
Okay.
an endpoint to our data set. Samples, I don't know. I'm not in a position to answer that question right now. I'd have to pull those up and look for you.
Questions, concerns? Yes, ma'am. Commissioner Deerhead.
Thank you. I just wanted to say a big thank you to you and your colleagues for all you did during that time. It's a lot of work and probably even putting yourself at risk at times, so we thank you for that. I wanted to make a comment or a question about the backup generator notes that were in the presentation. I noticed this past summer when I went to visit up in the mountains that there were some small treatment plants there that had no backup generation. There's no requirement, I'm trying to recall, for wastewater treatment plants to have a certain capacity of backup no matter what the capacity of the facility is. Can you refresh our memories about that?
I will try. There may be somebody that's better to answer that, but it's based on the capacity of the wastewater facility. Or if it's covered under the coastal regs, they have to have that redundancy. So it's a little different for areas that are in the zone designated for the coastal reg.
In planning for the future, would it be beneficial to modify those requirements to be more prepared? Is that something that would be helpful for the commission to explore?
I think it would. I think, the division certainly would support having alternate power supply or backup generators for all wastewater plants. It's required for all new pump stations, or they have to either have a backup generator or have to have the ability to supply a mobile generator.
Yeah, and that would be something I think Water Infrastructure could give us to, Kim Colson's group, because having been on that board, there's really not anybody out of compliance as far as having the required redundancy or backups. Sometimes it's a question of what kind of conditions it's in. But to my knowledge, serving on that board, and Kim could tell you more, I don't think there's anybody that's really asked for, we're non-compliant and we got to get compliant. It's more we keeping it up to speed.
I mean, but my observation was just in small mountainous subsheds where you have very small treatment plants, even though they're small and may not pass the threshold of requiring backup generator, their discharges could be quite damaging to small sensitive receiving streams. So it's just something to think about.
If I could too, just to add, some of the problems are a lot of times are on pump stations themselves, and it's a real hard break because there's some flexibility there, but a lot of utilities like to have portable backup generation so they can drive them around. The problem with a lot of resiliency type calculations for flooding is you get the electric panels up, but you don't get the roads up. So you can't drive them in, and you don't know it till really you try to drive in a portable generator and can't get it there for a pump station.
Right, and we also had some facilities during Florence that were so severely impacted that they lost their generators because of flooding, so yes,
Yeah.
just depends on the severity.
Yeah.
Other questions, concerns, comments?
I did have another question, and that is in terms of the loads from these storms from the wastewater treatment plants and the animal operations. Has there been any attempt to apportion the sources of the amount of load to each of these receiving waters, these river basins?
That's a very good question. I think the answer is no. And I'm assuming that's a portion, the nutrient loading.
Right, not the volume, but the specific
You know,
indicator
and
parameters.
And I think one of the reasons I think would be that, the numbers that I showed you are very large numbers, and that's volume of wastewater. Trying to determine the fraction of water versus normal wastewater concentrations with the rainfall that we experience would be very, very difficult, if not impossible, to come up with what those values will be. I think you could look at the information that Eric provided to see, what those nutrient concentrations in stream were and the recovery. But yeah,
It could be a good modeling exercise, I would think. Yeah.
Yeah, I think it would if we could actually come up with the volume of, or the portion of what was lost was actually wastewater versus water that they were pumping both to the wastewater treatment plant and pumping out of lift stations, for example. You know, if you go to a sanitary sewer overflow during dry weather, it's very obvious what's coming out of a manhole. If you go to a sanitary sewer overflow during a heavy rain event, it looks like water. So,
I would just add one light story that my husband's fished off of Morehead City in November for the past 15 years probably. And he said this was the worst year that they'd experienced in terms of catch. And so that could be a comment on his fishing skills. But I think it would be interesting to think about the long-term impacts because they said the waters were still quite stirred up. And I don't know whether that impacted the health of the fish or just their interest in nibbling on the hooks. I don't know.
Mr. Chairman, I had one other follow-up question sort of related to that, which was that I have been kind of wondering, and maybe because of the positioning of the storms, this didn't happen, wondering about whether there was any kind of signal in the sounds from the nutrient loads that went into the sounds as a result of the hurricane events, and haven't really seen much about that in any of the information from the department or in the press. Do you have any information about whether or not there has been any kind of a signal so far in the water quality and the sounds themselves?
I don't think the moment.
No, there has not.
Okay.
And as the summer heats up, we may see an increase in bloom activity in those areas this summer as those nutrients are consumed and that extra load is experienced.
So we'll wait and see.
Time will tell. Yes.
Thank you.
Thank you.
Other questions, concerns, comments? I believe that was the last item.
Although, Mr. Chairman, I have one item I just wanted to bring up for the information of the committee, if I may. And I believe this is the correct committee. It was reflecting a note I got from Annette Lucas. It appears that the storm, this is not for action today, but just a heads up for potential coming attractions. I think this is a relatively small matter, but I wanted to make sure the committee was aware of it, and I'll mention it tomorrow at the commission as well. And that is the stormwater program found that they need to make some technical corrections to the new water supply watershed rules that we approved in January of 2019. And for example, in the definitions rule, they inadvertently reference some parts of the 2B rules that are in the process of being moved or removed, and there's one incorrect reference to another part of another rule in 15A NCAC 0624. I don't think anybody thinks these are big deals, but Jennifer has recommended that we have these changes approved by the Water Quality Committee, the EMC, and the RRC. And so for members of this committee, there will probably be a request to do that coming forward to the committee in July. And they may include a request for a 30-day waiver to go before the commission. And again, these seem pretty ministerial. I think these are ministerial, but I wanted to give the committee a heads up that this may be coming forward.
If I may, I don't know if we've seen anything back from the RRC yet, but I would anticipate RRC has some changes they would like to make too. So I don't know, council and Director Culpepper could tell us, but these may be technical corrections that have to be done anyway with RRC comments too. I don't know if they're separate or together, but there may be.
So
There will be technical corrections, probably from RRC anyway.
So just heads up.
Okay.
Thank you.
Thank you. Okay, anything else? I believe that was the last item, and that was the last of the additional items, so this meeting is adjourned. Thank you. Thank you all. Jim and company, thank you very much.
CFPUA has now invested in their own fleet of fuel trucks, and they will hire full-time employees on 365 who are hazmat certified drivers.
Good for them. It's probably cheaper in the case.
Because they were not going to rely on EMS, emergency management, and they will drive their own trucks to the port, get their own trucks fueled, they'll drive everything off before the storm, they'll top the fuel trucks off and park them somewhere close by the different assets, that's what they did, because
Well, but see, the EMC, the emergency management center should be doing that. That command center should do all that. They said that let us take care of it.
and in the emergency